there. This is just to give a quick overview of the program that was written in Thani to get Lilybot to do obstacle avoidance. So the whole idea is when the program starts, Lilybot determines how far it is from an obstacle, and then once that distance is less than some predefined clearance value, which I specified as 20 centimeters, Lilybot first of all lights up its LED to let me know that there's an obstacle that has been detected, and then it stops for a little bit and then turns right. If it turns right and there's no obstacle, then it would move forward. But if there's an obstacle, it has to turn right again, reevaluate if it's too close or too far away, and if it's too close, it has to turn right again, but if it's already okay, it moves forward. The key thing to note when programming in Sony is when I run my program and I hit the stop button, sometimes the pulse width modulation pins which control the speed of the model or the wheels is left in an undefined state where the Raspberry Pi doesn't know what state it is, and so it gives me issues later on. To avoid that, we specify very clearly that whenever I hit my stop button, I want to set all those pins to 0. I'm also setting my direction and echo pins to 0 for robustness and redundancies. But that is all that I had to do. To get my main loop going, I had to of course define how Lilybot will move forward, how it would stop, and how it will turn right. Of course, I also had to define how it will determine its distance from an obstacle using inputs from its ultrasonic sensor. But once you're ready to run your code, you have to connect your Lilybot through your USB cable to your computer. You can see I'm ready to run my code, and I hit my start button to run my code.